Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll begin a discussion of Google Web Toolkit, which is a Java-based system for building rich internet applications. So now that web browsers have become more powerful and more standards compliant, they've enabled a new class of application, the so-called rich internet applications, or RIAs, that provide the same user experience as desktop applications. As a matter of fact, now, it's hard to tell an old-style web application from a new-style web application. It's just what people expect from the web. Google Web Toolkit is a toolset and a framework that hides many of the complexities of rich internet application development. It allows you to write almost exclusively in the Java programming language. And it feels a lot more like developing a desktop application than it does an application for the web. So we're going to talk about GWT, Google Web Toolkit. We're going to first get an introduction to rich internet applications. We're going to look at the toolkit itself, and then we'll dive into details in terms of things called widgets, containers, and event handling. Okay, so if you go back to the earlier days of the internet, there were significant differences between applications that were delivered on the desktop and applications that were delivered on the web. So desktop applications had an extensive widget set, buttons, scroll bars, trees, all sorts of stuff like that. Old-style web applications just had what was available in HTML forms, buttons, text, fields, etc. Desktop applications operated on a local machine, whereas web applications, all the data resided on a server, and just certain information was sent down to the client. Desktop applications were off-the-shelf software, and it was difficult to distribute updates. You actually, in the old days, had to get physical media and install it on your machines. For web applications, well, there's really only one version, the version that's running. And so you're always using the latest version. Desktop applications run only as fast as the local machine's processor, and can take advantage of all of the local resources. Web applications, though, especially in the olden days, suffered from possibly slow networks, and the fact that the communication between the client and the server was slow influenced the technologies used and also the capabilities of the applications. Desktop software, well, this is something that you installed locally on your machine. Users had a lot of trust that it was okay and would do the right thing. Web-deployed software, on the other hand, always seems like somebody else's, and so people weren't necessarily as comfortable having it do things like access files on their local machine. However, now we have web browsers that are sophisticated enough and networks that are fast enough so that we can provide a user experience over the web that really approaches that of the desktop experience. Rich internet applications leverage a number of technologies related to the web. There's HTML, which is the markup language for representing the visual components of an application. There's CSS, cascading style sheets, that provide the coloring and positioning, basically the look and feel of your application. Web browsers model pages using DOM, the document object model, and JavaScript is the language that's used on the browser side to implement application logic. There's also a special object in the browser called XHR, the XML HTTP request, which is an object that's available through JavaScript that lets a page communicate with the server without reloading. So gone are the days that you have to click a button and refresh your entire page just to get more information from the server. And so based on these technologies, there's something called Ajax, which is asynchronous JavaScript in XML, which requests a little piece of XML data from the server, which is then rendered into the page. XML or data in some other format. A lot of these technologies have been around for a long time. I mean, pretty close to 15 years, right? HTML has been around for longer than that, and CSS, well, it's taken a while to mature. But why did it take then so long, long in internet time anyway, a good 10 plus years for these rich internet applications to appear? Well, first off, browsers offer different levels of support for JavaScript and CSS. It was hard as an application developer to develop an application that would run and feel consistent across multiple different types of browsers, right? Internet Explorer, Netscape, Firefox, all these guys, Safari, implemented things in slightly different ways. It means that in order to test your application, you had to test it on many browsers. Also, a lot of the particular quirks of the particular browsers, how certain things would work, sort of boiled down to folklore. They weren't terribly well documented. Really, decisions didn't seem to be made intentional. So you just had these experts that you would have to employ that would know like all the browser, all the magic that you had to do to work with, IE5 versus Firefox 4. Additionally, JavaScript really wasn't well respected. People didn't view it as a real programming language. There are some reasons. There were lots of bad examples out there, right? It was, someone who didn't have a lot of experience programming that sort of just magically got stuff to work. JavaScript never really earned the respect of professional developers. It was also different enough from mainstream languages, especially the languages that server-side programmers worked with, C and Java and Visual Basic, that it just seemed like something else. And probably the biggest reason is that the support for the language was very spotty. Here again, different browsers interpreted things differently. There were different performance characteristics. Some things would be bad, some things would be good. And so then, even though JavaScript was very popular, it wasn't really well respected. And also, applications that were built for the web were very often aimed at the lowest common denominator. A lot of the initial popular web applications were for things like e-commerce, and they were going for a very wide audience. And so they had to make things very simple and very approachable. That is not scary. And they also wanted to support, old web browsers with slow connections and, let's be honest, naive users, right? E-commerce was trying to sell to a lot of people, and so then these sites, these user experiences, had to support people that were not savvy about using technology. So while all this stuff was limping along, there were some changes happening. JavaScript got much better support in browsers, and people had developed all of these libraries in JavaScript that provide a much more consistent experience across browsers. Things like Prototype, Scriptaculous, Dojo, YUI, the Yahoo UI, jQuery, things like that. All of a sudden, people started to understand what JavaScript could really do, saw the benefits of the language, and these libraries provided, again, a good abstraction over what was really going on in the individual browsers, so that people could be much more productive in JavaScript. Not only did browsers support JavaScript better, they also supported HTML and CSS better. And so now you didn't have to worry so much about the differences between browsers. And also, applications other than e-commerce were targeted to the web. Think about social networking, things like that are aimed at a different, more tech-savvy, and let's be honest, younger user base. And then Google comes along with things like Google Maps and Google World and Google Docs that really showed people sort of the art of the possible. There's this mythos behind Google Maps where it's like people saw it for the first time. It's like, wow, how did they do this? What browser plugin did they use? And then they started looking. It's like, wait, this isn't a browser plugin. This is all JavaScript. And it really blew people's minds because people didn't even realize that stuff was possible until they saw it done. But so even though they had made a lot of strides in supporting these technologies better, you still had to know them. You still had to learn a lot in order to build these rich internet applications. And that was the problem that Google Web Toolkit, GWT, was built to solve. It allowed rich internet applications to be developed using only Java, or really only mostly Java. You still have a little bit of HTML, you can still use CSS for styling, but the logic of your program, even though logic of your web application, even the stuff that ends up running client-side is all in Java. And so if you want to find more about GWT, there's the URL. So what does GWT provide? Well, a suite of classes that model UI components. So these are Java classes that model, elements of your web application, of your web page. If you are familiar with building desktop applications and something like Swing in Java, it should feel awfully familiar. So there are these objects that represent widgets, things like buttons, labels, tables, menu items, things like that. They're all objects, and you lay them out in what's called a container that contains widgets. And then when the user interacts with your application, there's an event model that allows you to handle events like moving the mouse, typing text, clicking buttons, stuff like that, and then do whatever it is your application needs to do. The way GWT does this is pretty novel. You write Java source code, and there is a special compiler that compiles Java, this Java source, into HTML and JavaScript. And so these are the languages of the web, right? These are the languages and technologies that your web browser understands. So it takes Java programming language, compiles it into HTML and JavaScript, and that is ultimately what's sent down to the browser and used. This has a number of advantages. First of all, it's very familiar to Java programmers. This is really why we talk about it here in this course, because it's not a new language to learn. It also allows you to leverage all the tools there are for Java. So you can develop your web application using your favorite Java IDE, and they even have ways of debugging your web application in IDEs. And you can use all your tools like find bugs, all your other code analyzers, because it's all Java source code. And also, because because it's compiled down into JavaScript, the GPT compiler can be really smart about the JavaScript that it generates, and can generate much more compact, efficient, highly optimized JavaScript than something that you'd write by hand. How does all of this work? Okay, so Java code is compiled and translated for the client. So you've got a GWT application, and there are two parts to it. There is the Java code for what happens on the client side, and then there's a Java code that happens on the server side. And the server side stuff is pretty much like what we learned about in the web lecture, right? You've got a servlet and a Java web container. Really, there's nothing special there. There's a couple of libraries, and we'll talk about that in a little bit. But it's just plain old Java code on the server side. On the client side, there is a special section of your application for working on the client. So this is the code that handles user interface layout, handling events, the logic for displaying and updating your UI, good stuff like that. The convention is to have the code for the client side in a package that has client at the end, something like edu pdx cs410j gwt client. And so your code lives in this client directory, and then the GWT framework itself provides a number of client packages for here again representing widgets and things like that. And it also provides the ability to use a subset of the standard Java classes, it's something called Jre Emulation. So even though your client code is Java that gets compiled into JavaScript, GWT supports a handful of standard Java classes from the JRE that are used that can be that basically provide JavaScript implementations of them that then can get bundled and sent to your client. So a number of classes from Java Lang are, for instance, wrapper classes like capital I integer, booby boolean, math, string, string builder. Many, if not most, of the collections from the Java util package. Also, date, comparator, our old friends there. And so you can see how this allows you to leverage everything that you've learned in this course to then build these rich internet applications. You don't need to learn a new API. Now that being said, there are some concepts in the Java programming language and some APIs that can't be accurately represented in JavaScript. So for instance, in JavaScript, numbers are always 64-bit floating points. And so this means that if you're doing a lot of arithmetic with 16 or 30-bit, 32-bit values in Java, you're not going to get exactly the same behavior. The support for stack traces is a little different. They've made great strides sort of bringing it up to par with what you get in Java, but JavaScript doesn't support stack traces as well. So you don't get everything in JavaScript that you do in plain old Java. Now, JavaScript is inherently single-threaded. All of the threading-related operations, like the synchronize keyword, wait notify, stuff like that, well, they're just ignored. They don't do anything in the when the code is compiled into JavaScript. Both Java and JavaScript support regular expressions, but they're not exactly the same. So be sure to use the subset of regular expression support that overlaps both languages. But really, there are only a handful of caveats. Everything else works the same, and I'm guessing that these are the kind of things like lots of numeric operations or big complicated regular expressions are probably not things you're going to want to do in your client code anyway. You're going to save that kind of stuff for the back end. Now, there are some APIs that just aren't conducive to JavaScript, or probably more accurately, the guys at Google decided they didn't want to re-implement all of that functionality in JavaScript. So instead of using the Java APIs for things like parsing dates and times and parsing numbers, the GWT JavaScript, the GWT emulation mode has classes like datetime format and number format for working with dates and times, and also their own timer class for having events fire at some regular interval. And finally, if you've got an object that you want to send between the client and the server, you can use Java IO serializable or the GWT is serializable interface to do that. So there are a handful of standard Java classes that GWT knows about. So I already mentioned that there are separate packages for your client-side code and your server-side code. Here's kind of the way your code layout works. Really, they're just Java packages and a couple of extra files. So let's say you've got the root of your source, then you've got com my company my app. That's sort of the root package. We've already mentioned there's client-side source code that goes in that. So you might have myapp.java that determines defines the entry point for the application, and we'll talk about what that means in a couple minutes. So you've got the client-side code, and then you've got the server-side code. So this is all Java code. That's the client stuff is compiled down into JavaScript, and the server-side code is deployed into a web container. There's also something called a module configuration file, which is something like myapp.gwt.xml, and this configures the GWT application itself. And then this is used by the compiler and some things on the server side to determine how everything is laid out, or how everything how everything is configured, how certain things are configured. There's also, by convention, a directory called public underneath your root package directory, and that's where static content resides. Things like your HTML, your CSS, maybe any images that are used in your GWT project. That's where all of that lives. Okay, so I mentioned this thing called a module in GWT. Well, that's basically the configuration for the application or the library that's written in GWT. The configuration resides in a file with the .gwt.xml extension, and the module gets its name from the name of that file, and it's kind of like a class name, right? You would see things like com my company my app, which is defined in myapp.gwt.xml. And modules may inherit from other modules. It's kind of like importing stuff from another module. And so what happens very often is that you have a GWT application that then inherits stuff from other libraries. So for instance, a library is just GWT application. And I guess why it's interesting is that the module contains both, well, it definitely contains client-side code. I can't remember if the module contains server-side code, strictly speaking. But definitely client-side code. This is all needed by the GWT compiler and stuff like that. So if you're writing a GWT application, you'll most likely inherit from modules like com Google GWT user that lets you use all of the standard widgets that come with GWT. Modules can also rename the URL so that they look nice. So that you're not, going to some random HTML file. You can just go to a simple URL. And the GWT module configuration also defines what's called an entry point class. It's like a main class. It's a class with a main method in it. It's basically here's where the application starts, or more strictly speaking, when the web page is loaded that contains your application. Here is the first method. Well, here's the method to invoke. So I had to abbreviate some of this stuff so it all fit in the page. But here's what a module might look like. So here in examples.gwt.xml, we'd have a module declaration say, hey, we want to rename this to examples, which makes the URL a little nicer. And we'll say, hey, it inherits the user module, and it's got 2 entry points, examples, and hello. Most often, your application will only have 1 entry point. This example shows that you can have more than one. So that was the module configuration file. There's also something called a host page, which is the HTML that is rendered, well, for the application. So this is something a little different about rich internet applications and GWT applications specifically. There's usually only one HTML page. It's not like you're going back and forth between multiple pages. So a page is only loaded once, and all the JavaScript is loaded and rendered. And then as you interact with that page, instead of reloading the entire thing, the client makes calls to the server using that XHR, that XML HTTP request object, to then fetch certain pieces of data that are then used to redraw certain portions of the page, right? We'll see a number of examples of this once we start looking at GWT applications. But anyway, back to the host page. The host page is the HTML page that is loaded by your GWT application. It can have anything that an HTML page can have, right? It can have, various text and stuff like that. It probably doesn't have too many widgets, though. That's actually defined as part of the application. But what is important is that you include in this HTML page a script tag to load the script, the JavaScript, which is your compiled application. So if you want to, this is for the examples application, we load the examples.nocache.js page. I don't know if we'll go into details about the nocache and the various other JavaScript files that are generated. Basically, nocache ensures that when your page is reloaded, you get updated JavaScript. This HTML page is sort of the container, the top level container that your application runs in. And inside your GWT code, your client-side code, you can get at the body tag here as an object called the root panel. And so then you can populate the contents of that root panel programmatically in Java, and then that'll get rendered in your HTML page. It might also be that here in your host page you have other HTML elements. You might have divs or spans or something like that. You can get at those objects, again, programmatically in your Java source code, which gets compiled down to JavaScript, using the get method of root panel. And you give it an ID. And this is the ID of the HTML element, so I don't have an example of it here, but I could have a div with an ID of appointment for an appointment book application, and then you could populate that with populate it programmatically with GWT code that gets compiled down to JavaScript. Okay, so here we're kind of walking through what you need for a GWT application. First, you need a module configuration file. Then you need a host page. And now, okay, let's look at some Java code. So this is what Hello World looks like in GWT. Well, it's plain old Java code. We have a handful of classes and interfaces that we import. And here is your class. So here we have a class hello, and it implements an interface called entry point. This is where the application is going to begin. This is the method that's going to be called when your web page that contains your GWT application is loaded. Entry point defines one method on module load that you have to implement. And what do we do when our module is loaded? Well, we're going to create a new button object. So this represents a button widget on your web page with the text hello world. And then we're going to simply add it to the root panel. So again, an application begins with on-module load. This is sort of the code that's invoked first. And note that a module may have multiple entry points, but I think most often you're only going to want one. Okay, so Google Web Toolkit was built with, well, developers in mind. And in order to ease development of these applications, there are two modes of execution for a GWT application. Something called hosted mode and something called web mode. So hosted mode is what you use during development, and this runs your application in a special way. There is a Java program that essentially simulates the browser. Client code itself is not translated into JavaScript. And because it's all running in Java, it means that you can use a Java debugger to attach to the program, this hosted mode. And you can set breakpoints. And so you work with your code in a browser, but what that browser is doing is communicating back with this hosted mode application. And as you click through things in your browser, it then executes Java code and will hit various breakpoints and let you examine values and things like that. It also allows you to refresh the application to pick up any client-side changes. So you can make changes to your Java code, hit refresh, and see them automatically updated. Instead of running error messages to the JavaScript console in your web browser, in hosted mode you get log messages written to, well, a special log window in the hosted mode UI. And you can do this by calling the log method of the magical GWT class that comes with the GWT API. Your entire application is run in one VM, and it uses an embedded Jetty server, Jetty web container, to serve up the static content like your host page, your host HTML, and any images and CSS that you might have either, and also run the server-side Java code that then handles requests from the browser from your client code. Note that if you do have a server, maybe you want to run in Tomcat or something like that, you can configure hosted mode to point off to a different server backend, but there's no real reason to do that. So you develop your GWT application in hosted mode, but you deploy it and do your final testing in web mode. In web mode, the client code is actually compiled from Java down into JavaScript and is bundled and deployed into a web container. So basically what you've got is a plain old Java web application. The biggest difference is that the HTML, CSS, and JavaScript are generated by the GWT compiler instead of having you write it yourself or use whatever other tool set that you would use to normally develop it. This is basically what you would do in production. And then here again, web mode is for your final testing. It allows you to verify that things work, look, and perform like you'd expect. So as you can imagine, there are a number of parts here. There are tools you need to download, like the SDK for GWT. You need to get the compiler, and then running in hosted mode. You can imagine there are various scripts and things like that. And that's not what I want you to focus on in advanced Java programming. I want you to be able to focus on the application and not all the tools surrounding it. So there is a good GWT plugin for Maven that makes things a lot easier. And you can go to that URL and read all about it. It downloads GWT. It will compile your application. It'll launch hosted mode. It'll assemble the WAR file so you can work in web mode. All sorts of good stuff. Now there are a number of dependencies that will rely on GWT, so it's probably a good idea that when you work with GWT, you define the version of GWT that you want to use just once and put it in a Maven property. So in your properties section of your pom.xml, define a variable called property, something called GWT version. There is also a standard archetype for creating GWT projects. This GWT Maven plugin will support supports archetypes and will give you a layout that looks something like this. For your projects, though, I've provided an archetype that not only creates all the files, but also has starts you off with a very simple application that you can then adapt to build your application on top of it, kind of like what we saw with the REST/web application. Because GWT is just a bunch of Java libraries at the end of the day, you can depend on them just like you would any other third-party library. So you configure your dependencies for like the GWT servlet, which is the stuff that handles the backend code. We'll learn a little bit more about that later. And then the stuff for the front end, things like GWT user. Oh, a little footnote here. The GWT hosted mode runs out of an exploded war directory, so you need to have a little bit of extra configuration for your Maven build in order to get everything to work together correctly. So for instance, you need to set your output directory to war/web-inf/classes to make sure that everything gets compiled into the right location. Finally, you need to tell the GWT Maven plugin which modules to include and where you expect the application to reside, and you can do that with this configuration right here. Again, I'll let you go off and read up on details, or you can just take what the archetype gives you and you can start from there. So the GWT Maven plugin provides a couple of Maven goals. GWT Run, which will build the project and run in hosted mode, so you can use it to debug. You can use it to easily make changes and recompile. If you want to run hosted mode waiting for a debugger to attach, you can say GWT debug. And you can also run the GWT unit tests. These are the GWT test cases using the special GWT test mode. We'll see more about this at the end of the GWT discussion, but there is special support for testing client-side code written in GWT. If you want to run your GWT application in web mode from using Maven, you need to do a little bit of special configuration for Jre. You basically need to tell it where the WAR file lives, where the XML lives, stuff like that. So really not that much different from working with regular Jre. Again, the archetype will take care of this for you. Okay, now that we've talked about these concepts like GWT hosted mode, and we've looked at how to configure Maven for building and working with your GWT application. Let's see what it really looks like. Okay, so here I have my example GWT code, and I am going to run Maven GWT run. So this will launch GWT hosted mode for the application. Of course, it'll go and compile the source code. I've done that already, and so it's not going to do it again. And it launches this application called GWT development mode. And so what it allows you to do is maybe start, to launch your application here in your default web browser. It's going to bring up Chrome, a new tab in Chrome. It does take a moment for it to load in development mode. It's not always the fastest technology in development mode, but once it's run into web mode, it's super, super fast. Okay, so this is what my example GWT application looks like. We'll be going into details of what all of this stuff is in a later screencast when we dive into what the actual individual widgets are. So this is what you get, and now you can work with your application. But I just want to take another minute and take a look, go back to development mode here and see what we've got. Any messages written by your application would show up here, but you can also get insight into what's happening on the server. There was a request made for a post to gbt.rpc from the examples application. And you can also see this is the requests that are coming from the particular this particular Chrome browser. So as you can see, it's asking for this URL, which sure enough is the URL that's there in Chrome. And it tells you that the examples module had been loaded. If a problem occurred when the application was loaded, when the examples application had been loaded, you'd find out about it here. So anyway, as you work with your application in development mode, this little UI here will help you do that. And by the way, this is GWT development mode. So this is that Java program again that is running all of your Java code, all of your client-side code as Java, not JavaScript yet. And actually, there's a special browser plugin which is used to interact with it. And so I guess you don't see it on my machine, but the first time that you guys use GWT, you'll very likely have to install the browser plugin, which does all this magic for communicating all of the browser events back to your application that's running in pure Java. And like I said, if we had launched this with GWT debug, then we could attach this Java process with a debugger and then debug that. Okay, and I think that's where I want to end for now. So this was an introduction to GWT. In our next screencast, we'll start digging more into the GWT API, and we'll see how all of the visual layout and all of those widgets and stuff is actually done. So, as always, thank you for watching the screencast for Advanced Java Programming at Portland State University.